Welcome to Lesson 6 of Control Theory. Today, we'll learn how to draw block diagrams. This is an essential skill for visualizing and analyzing control systems. There are 4 main steps to draw a block diagram. Step 1. Identify the input and output. Step 2. Write the differential equation with all derivative terms. Step 3. Convert to integral form and write the equation starting with y equals. Step 4. Draw the block diagram based on this equation. Let's look at each building block we'll need. The first building block is the gain block. When you see a box with a constant like a or k inside, it means the output equals the input multiplied by that constant. So, if u enters and y exits, then y equals a times u. This simply amplifies or scales the input signal. You can use any constant, a, k, or any other letter. The second building block is the integrator. We show it with an integral symbol inside the box. When input u passes through an integrator, the output y equals the integral of u with respect to time. This is fundamental for converting differential equations to block diagrams. Now, what if we need to multiply by a coefficient and integrate? We can show this in 3 equivalent ways. Let's call them 2.1, 2.2, and 2.3. 2.1. A single block containing both a and the integral symbol. 2.2. First multiply by a, then integrate. 2.3. First integrate, then multiply by a. Here's the key insight. All 3 give exactly the same result. The order of multiplication and integration doesn't matter for these linear operations, so 2.1 equals 2.2 equals 2.3. The third building block is the summing junction, shown as a circle. This is how we represent addition and subtraction in block diagrams. Let's start with basic addition. If signal A and signal B both enter the circle and C exits, then C equals A plus B. The arrows pointing into the circle indicate what gets added together. The arrow leaving the circle shows the result. You can have more than 2 inputs. For example, if A, B, and D all enter the circle and C exits, then C equals A plus B plus D. All incoming signals get summed together. For subtraction, we put a minus sign next to the incoming arrow. If A enters normally and B enters with a minus sign, the output C equals A minus B. Think of it as C equals A plus negative B. Now let's look at a more complex example. How do we draw A plus B minus C minus D equals E? There are multiple ways to do this. Let me show you 3 different approaches. First way, use a single summing junction with 4 inputs. Signal A enters normally. Signal B enters normally. Signal C enters with a minus sign. Signal D enters with a minus sign. The output is E. This works, but it can look complicated with many inputs. Second way, use multiple summing junctions in series. First, add A and B to get a partial result. Then subtract C from that result. Then subtract D to get the final output E. This approach is cleaner and easier to follow. Third way, group the operations. First, add A and B in one junction. Separately, add C and D in another junction. Then, subtract the second sum from the first sum to get E. All 3 ways give the same result, so choose whichever is clearest for your diagram. Let's summarize what we learned. We have 3 main building blocks: the gain block for multiplication, the integrator for integration, and the summing junction for addition and subtraction. For integrators with coefficients, the order doesn't matter. Multiply then integrate, or integrate then multiply, both work. For summing junctions, you can combine multiple operations into one circle or chain multiple circles together. With these tools, you can construct any block diagram. In the next lesson, we'll apply these concepts to draw actual system diagrams from differential equations. See you then.